In this video, we'll learn how to solve an ordinary differential equations using substitution method. Okay, let's see. We have the following differential equation. Y prime equals 4x minus y plus 1 squared. We'll label it as equation 1, and we're given the initial value. Y0 is 2. To solve the initial value problem, we need to solve the ordinary differential equation 1. And you can see on the right hand side is the function of 4x minus y plus 1. So I can form a like y prime equals fxy, f of ax plus by. Normally we'll set a new variable z equal ax plus by, and then when you differentiate both sides with respect to x, we obtain dz over dx is a plus b times dy over dx. And then you plug in the equations. You have dz over dx will be a plus b times f of z. So here we substitute dy over dx as f of z. And then you see the resulting equation is separable. So that's the core idea of substitution method. We start from a very complicated differential equation, and we want to some way to substitute to create new variable, and then we end up with a hopefully simpler, easier to solve differential equation. And here the resulting equation is separable, so it can be solved easily. So we set z is equal to 4x minus y plus 1, and we obtain dz over dx is 4 minus dy over dx. And from the equation 1, we have this one is 4 minus z squared. Now, notice here that we will have two cases. Case 1, we have to consider if z is equal to plus or minus this one 2. So you see here the right hand side, when z equals plus or minus 2 is 0, and since z is a constant, its derivative with respect to x will be 0. So both sides are 0. So yes, z equals plus or minus 2 is our solution. However, when you plug in, you get y is 4x plus 1 minus z. And you get y0 is 1 plus or minus 2. And this one, of course, is different from 2. Therefore, the first case does not happen. So we move on to case 2. You know that z squared minus 4 is non-zero. The obtained equation is separable. Now, we're going to use partial fraction decomposition. Then we integrate both sides and we obtain the logarithm of just plus 2 over z over z minus 2 equals 4x plus some constant c. Then we have this was exponential c exponential 4x, and because we break the absolute bars, so we need to add plus or minus sign here. And we will call this constant is 1. You can say c sub 1. Here, I want to break down the rational expressions into 1 plus 4 over z minus 2. solve for z, we obtain z equals 4 over 1. Maybe it is much better to use minus u1. So you have here is 1 plus c1 times the exponential of 4x plus 2. Now let me check again. This one is minus 4. Coming back to the problem, we want to solve for y. We want to express y as a function of x, not z. So we substitute y is 4x plus 1 minus z, and y will be for x minus 1 plus 4 over 1 plus c1 times e to the power of 4x. The initial value gives us c1. Now plug in here. You have 2 plus 1 is 3, right? So 3 is 4 over 1 plus c1. So 3 plus 3 c1 is 4. So c1 is 1 over 3. Yeah. So our explicit solution is y equals 4x minus 1 plus 4 over, this one is 1 over 3, so we have this one 3. This one will be 4 times 3, right? The interval of definition is minus infinity to infinity.